Hello, my name is Christian Humbert from the company AbsInt. Many people are nowadays using continuous integration systems like Jenkins to manage their build process. We at AbsInt offer verification tools to compute worst-case stack and worst-case execution time analysis solutions. These two classes of analysis work on binary level, and we highly recommend to perform these static analysis whenever there is a new version of the binary available, so especially also in a continuous way. So wouldn't it be a natural thing to consider the static analysis part as the final build step in your build process? The answer is yes, and therefore we created the AbsInt Jenkins plugin for the binary level analyzer. In this tutorial, I'd like to show how to install, configure, and use the Jenkins plugin. So let's start with the installation process. For that, go to Manage Jenkins section, switch to the Manage Plugins, and here the easiest way is to really download and install it directly from the Jenkins plugin server. To do so, switch to the Available tab here. It takes some seconds. And, well, apply a filter, for instance, AbsInt, ABS-INT, and you will find the two available AbsInt plugins. One for the Astray and Rule Checker toolchain, and one for the binary level analyzers like TimingProfiler, TimeWeaver, and StackAnalyzer. And this tutorial covers the binary level plugin. So tick the option here and click on Download Now and install after restart. You're probably familiar with that. You have to restart the Jenkins server whenever you install a new plugin. So let's wait for that. When the installation is done, we need to configure the plugin. This will be done under Manage Jenkins, and we need to go to Configure System section. Here we have to scroll down until we find the A-Cube configuration section. And now we have basically two ways to tell the plugin where to find the A-Cube installations. So either you manually install all relevant A-Cube analyzers for the various targets you're using on the Jenkins nodes, and then you provide the path to the AbsInt Launcher program, which is typically that one under Windows, or you provide the path to the A-Cube installation packages only. So in my installation or in my system, I have it here. I have one A-Cube for PowerPC and an A-Cube for TriCore for the various platforms for the Linux and Windows 64-bit platform. And these are just the installer packages. And it's only sufficient to provide this path here to the installer packages, and the Jenkins plugin will then automatically copy the relevant installer to the Jenkins workspace, unfold it there, and execute the analyzer from the workspace. So for the rest of the tutorial, I'd like to follow this variant. What you have to do in any case is to provide information about the license server. So with the latest release, AbsInt introduced floating licenses, which you need to work with the Jenkins plugin. And here you need to specify the name of your license server of the computer. And in my installation, it's here, makefactory.absint.com. And we are using the default port 42424. But what happens if you're using a distributed build system with the various Jenkins nodes running distinct operating systems? Then your paths to the AbsInt Launcher program or the installation packages might be dependent on which node you are running the analysis. In this case, we would recommend to use environment variables like this one here. Of course, you need to set or register these environment variables on the specific or on each Jenkins node. And you can either do that manually in the system, or I'd like to show you how to do that in the Jenkins node configuration. For that purpose, let's switch to the Jenkins setup again. And this time click on Manage Nodes. So in my scenario here, I have one Jenkins master running on my Windows system, and I have a Jenkins slave, just one, running a Linux system on it. And now you can go to the node configuration by clicking on it and switching to the configuration of this node. Here you can tick the option Environment Variables and click on Add to add a new environment variable. Since we are using the ACube installer variable, we should better provide the corresponding value here. So this is my master, this is the Windows system. In my Windows, I have the installation packages lying here. So you can save it there. Now let's go back to my Linux system. It's that one. Click on Configure. And also take the option Environment Variables. Add the very same variable. But this time, let's provide the path where the installer packages lie here in my Linux system. Well, this concludes the configuration of the plugin. Now it's now time to make an example how to use it. Alright, then let's create a new build job by clicking here. For this example, it should just be a freestyle project, and let it have the name HRIPPC demo. All right. So the new build job has been created, and in order to have the stack analysis as a build step, we just need to go here to the build section and say add build step, ACube analysis run. You see, you have done a new configuration window where you have to specify the project file, the APX file here. And in my example, I have already an existing binary, which I will work with. And I just need to refer to the existing project file. So it's lying in this directory here. So let me copy it. It's called scenarios ACube APX. If I'd like to restrict the analysis to a certain analysis item, to a certain ID, I can here provide a list of analysis IDs. If I let it empty here, then the analysis will perform all items listed in the APX project file. So let's have a look for it. Without clicking on the APX, the ACube will be opened, and you see we have lots of items specified here. So especially 11 analysis items, so timing and stack analysis, and the value analysis here, but also 2 result combinations. You also see existing analysis results and some errors here. We will see the effect later in the Jenkins execution when we are faced with these errors. So let's come back to the configuration. Next thing you can choose is when to let fail the build process. Yeah, because there is a so-called pedantic level which you can specify in the APX configuration, but you can override the one specified in the APX by choosing the option here. You can, for instance, say, let me fail the build process here only when I have fatal errors. but you can also already let it fail by some errors or even warnings. This would be a pedantic high level. So let's switch here to errors and warnings. That means as soon as I have at least one warning, of course, or an error, then I would let fail the whole build process in my Jenkins configuration. Okay, then there are some remaining options you can choose from. For instance, if you'd like to export an ACube workspace file, which I would always recommend, and for instance, let it export and archive in the Jenkins workspace, because then you would have the advantage to at the end of the analysis always come back to the workspace, open it, and see directly the results. You can additionally check the options to copy the report in XML resort files, or to have a demo run to skip the whole analysis to check if the configuration is correct here. I would stick with these options, save the configuration, and now it's time to perform the analysis. Okay, let's start the build process by clicking on Build Now and see what happens. Well, it's already over. It failed very quickly, and well, let's have a look to the console output to see what was the reason. All right, yes, I mean, I have here a distributed build system. Remember the installation and configuration part. My master is a Windows system here, but I also have a slave, a Jenkins slave, which is a Linux system. And now that I've tried to build the process, the master distributed it or forwarded it to its slave, to the Linux system. And of course, in the Linux system, as you can see here in the output, the project file here from the Windows path wasn't found. So there was an IO exception because the project file could not be found, and so the build process failed. That means we have to change or adapt the configuration a bit. Let's go to the configuration of the project. And here in the ACube analysis run, we have to replace this Windows path here to, again, a corresponding environment variable. And I have prepared that already. It's called ACube projects. That's an environment variable which is set differently for the Linux and the Windows machine. But both contain the very same content, namely the analysis project. Okay, let's save the project and try it again. Wow, it seems to run a bit longer now. Switch to the console output to see what happens. All right, the build has already finished, well, with the failure as a result. And what is the reason? Let's have a closer look to the output here. So first of all, it found now the project file. Then we have chosen in the configuration that we'd like to copy the installer package and unfold it to the Jenkins workspace and run the ACube analyzer from there. So it has found the corresponding installer package on the Linux system. Therefore, we have a Linux tgz file. It set the toolpath to the corresponding locally unfolded tool, did some compatibility check, and started the analysis project. We have seen that before, that we have these 11 analyses plus the 2 result combinations, and here is actually the result in some tabular overview. And what you can see on directly is that we have 2 analysis items, namely that one, which failed. This was a TimingProfiler analysis, and we have here a stack analysis which failed. Here's again an overview about the failed items. And If you like, you can do a double click, you can follow the link here on the failed analysis items to see actually the HTML report file of the analysis. And from the message details below, you already see what happened, namely that the computed timing bound, which was 2.446 milliseconds, was not in the expected range. The expected one was just a limit of 2 milliseconds. Yeah? The same actually here can be seen in the stack. Here's the HTML report overview. And here as well, the computed worst case stack usage was 304 bytes, which was higher than the expected upper bound of 300 bytes. Okay. Another advantage of this plugin is, and the configuration we did, that the workspace file, the acube workspace file, was archived in the Jenkins workspace. That means we can now go back to the project workspace file direction, and well, here in the since we had build 2, can go to the build 2 directory, and we will find the workspace file here, which is the last one, the APX. And by just clicking on that, it will be downloaded from a Jenkins server, and you can open the workspace file in your local installation of acube, for instance here in the Windows machine, as if you had done this analysis right now on your machine. You see the results and the overview about all analysis items here, and you could, for instance, closely investigate why, for instance, this analysis 8, the stack analysis, failed, and do a double click, have a look, and you see, well, my worst case stack usage was 304 bytes, and well, in the configuration of the project, we were sure that we just have a limit of 300 bytes. So we must find the reason now and either change or modify the software so that we come again below the 300 bytes stack usage, or increase our expectation, of course. All right, so this concludes the tutorial and the introduction to the Jenkins, the AbsInt Jenkins acube binary level analysis plugin. If you have any problems during configuration and usage of the plugin, please feel free to contact us, drop us a mail, give me a call. support@absint.com will be ready to support you. Thank you very much for your interest. Bye-bye.